So formula mass. We've talked about how to figure out what the formulas are now. The formula mass is the average mass of an individual molecule, or formula unit of that compound. It is sometimes called the molecular mass or the molecular weight, but the preferred term is formula mass. It's the mass of one formula of the compound. So it's the sum of the masses of the atoms in a single molecule or formula unit. We've talked about atomic mass. That's the mass of one atom. So this is the mass of one formula. And this is actually a very simple concept. The mass of the whole thing is just the sum of the parts. If you had a box and it had 5 apples and 2 oranges in it, and you knew the average mass of apples and oranges, you could figure out the mass of the fruit in the box, right? You just add them up. So the formula mass, we take the number of the first element, number of atoms of the first element, times the atomic mass of that one, plus the number of atoms of the second element, times its atomic mass. And if you have more elements, then you just keep going. Oh, I've got 2 hydrogens, 2 times the mass of hydrogen. So let's do an example. And we're going to practice some nomenclature in here as well. Calculate the formula mass of calcium nitrate. Well, to find the formula mass, we need the formula, right? So calcium nitrate, what kind of a compound is that? Ionic. It's ionic because the first element is calcium. So we need to write the formula. So we've got calcium. There's no Roman numeral here, but what's the charge on the calcium ion? 2 plus from its position on the periodic table. And then nitrate, what's the formula for that? NO3 minus. So this has a -1 charge, this has a +2 charge. So in order for them to get together and have an overall charge of 0, we need 2 nitrates. So we have NO3, 2. 2 of those bundle packs. Now that we have the chemical formula, we can calculate the mass. So we have 1 calcium, and calcium is what, 40? 40.08. So what's the unit when we're talking about 1 atom of calcium? AMU. So that's 40.08 atomic mass units. And then how many nitrogens are in this formula? 2. Because we have 2 of these bundle packs, and each of those packages has 1 nitrogen. So we have a total of 2 nitrogens, and then we look up the mass, the average mass of nitrogen, which is 14.01 atomic mass units. How many oxygens? 6. So I didn't plan this well. Plus 6, and the average mass of oxygen is 16 atomic mass units. So I have rounded my masses to 4 significant figures. That's fine. Don't round more than that. You're welcome to show all of the digits that are on the periodic table. So I've got 40.08 plus 2 times 14 plus 6 times 16. So 164.1 is what my calculator tells me. So what about sig figs? I am fine with you saying that, oh, well, this should have 2 decimal places and sticking a 0 in there. I'm okay with that. I am also fine with you saying, well, all of these had 4 significant figures. I'm going to have 4 significant figures here. There are some weird things that can happen when you break over 100, and stuff happens with the sig fig rules, and so they're kind of odd. Bottom line, though, when you're calculating formula masses, you're never going to end up with a bunch of garbage after the decimal point. Okay, so what I do is I just write down all the digits, And usually this number in a calculation is not going to limit the number of significant figures. So just write down all the digits and don't worry about it. But that's the mass of one formula unit of calcium nitrate. Any questions? Does calcium nitrate have molecules? What kind of a compound is it? It's ionic, right? Ionic compounds don't have molecules. They have formula units. So that was the formula mass, the mass of a formula unit. The molar mass is the mass of a mole. So we learned what a mole is, right? Mole is Avogadro's number of things. So the mass, this is the mass in grams of 1 mole of the molecules or formula units of that compound. And what's great about the definition of atomic mass unit and the Avogadro's number is that this is numerically equivalent to the formula mass. It's just a different unit. So what's the molar mass of ammonia? Well, what's the formula for ammonia? NH3. So we've got 1 nitrogen. We have 1 mole of nitrogen. So how much does 1 mole of nitrogen weigh? What's the unit? One atom weighs 14 atomic mass units. 1 mole of atoms weighs 14 grams. And we have 3 moles of hydrogen, and a mole of hydrogen weighs 1.008 grams. So 17.034 grams is equal to 1 mole of ammonia. So significant figures. You'd probably say that 3 is the last significant figure, because this one ends in the 2nd decimal place, this one ends in the 3rd decimal place. And if you think about, anyway, it's not worth, I'll stop now. So that's the mass of 1 mole. What is the formula mass of ammonia? (17.034 AMUs). It's the same number. We don't actually use formula mass very often because we don't end up talking about individual formula units or molecules very often. This is the one we use the most. They are calculated in exactly the same way. The difference is the unit. So we use the molar mass when we need to count molecules or formula units by weighing them. So just like we learned how to count atoms by weighing them using their atomic masses or the mass of a mole of them, we can do the same thing with molecules. So if we have grams of a substance and we want to know how many molecules there are, we'll convert grams of that substance to moles and then use Avogadro's number to figure out how many molecules are in there. So grams of A, we use the molar mass, how many grams per mole is in here, and then we have Avogadro's number, that many molecules of A in 1 mole. And we put those in there so the units work out. The grams cancel and the moles cancel, and we're left with molecules. So here's an example. Find the number of ibuprofen molecules in a tablet containing 200 milligrams of ibuprofen. And we're giving you the formula because we don't expect you to know that. So we read the problem. Always a good strategy to pull out any numbers that are in there. So the only number that's in there is 200.0 milligrams. And that's milligrams of ibuprofen, C13H18O2. What are they asking us to find? Molecules of ibuprofen. So we're looking for molecules of ibuprofen. So we have to figure out how to get from here to there. Moles in the middle. So if you're like, I'm not sure where to go, try moles. See if moles helps you out. So if I had moles in here somewhere, could I convert moles of ibuprofen to molecules of ibuprofen? Yeah, that's Avogadro's number. So I could put moles in here. Milligrams to moles. What did we just learn how to convert between? Grams and moles, right? So if I had grams in here, I could convert to moles. That conversion factor is the molar mass, right? And this would be milligrams to grams, and we should be able to do that, right? Because we know what the prefix milli means. So I've come up with the path. That's the hardest part. Now I look at my path. There's three arrows. I'm going to have 3 fractions. So 200.0 milligrams. It's probably best to write the chemical formula. But when I look at this, I'm starting with ibuprofen. I'm ending with ibuprofen. The compound isn't changing, so it's okay to leave it off. We'll see later where the compound changes, and then you have to write out milligrams of what. So I'm going to convert this to grams. I'm going to have milligrams in the bottom, so those cancel out. And then I'm going to convert this to moles and grams on the bottom, so those cancel out. And then I'm going to convert this to molecules with moles on the bottom, so the moles cancel. So my path was milligrams to grams to moles to molecules. And that's what I have here in the numerators. Milligrams to grams to moles to molecules. I take this unit, put it in the denominator of the next term. This unit goes down there. This unit goes down there. It's a pattern. The units are going to cancel out. I need to put the units in first because they're going to tell me where I put the numbers. So much less thinking this way. Okay, so grams and milligrams. Well, what does milli stand for? 10 to the negative 3. So I've got milli in the bottom. I'm not going to put what it means next to it. I'm going to put it on the other side. So milli stands for 10 to the minus 3, which is the same as 1 times 10 to the minus 3. And now that's scientific notation. I can stick that in my calculator very easily. The gram here is like someone's last name. I'll pick on my son Tommy. So his full name is Thomas Kawagoa, right? So this is like the full name. Here's the full meaning, Thomas Kawagoa. But we rarely call him that. This is his nickname. Milli is a nickname for 1 times 10 to the minus 3. Milligram, Tommy Kawagoa. So here's Thomas Kawagoa and Tommy Kawagoa. We never call him Thomas Tommy Kawagoa. Or, just Kawagoa. He doesn't get called that because there's too many of them at school and nobody knows who they're referring to. He does get called K3 sometimes, but because he's the third one. So it's really important to get the metric unit conversions straight because they're going to crop up all over the place. And I'm seeing in my 1B students who have successfully passed 1A that some of them are still doing this backwards. And they're not doing very well on that exam because they screwed up. So it's important to get that straight. And if you have trouble with it, please talk to me. And I'll help you. So here, moles and grams. What number do we need in there? The mass of ibuprofen, right? The molar mass. So we have to calculate that. So the formula, there are 13 moles of carbon in 1 mole of ibuprofen. So 13 times the molar mass of carbon plus 18 times the molar mass of oxygen, hydrogen, and 2 times the molar mass of oxygen. I did the math there by mistake. So 13 times 12.01 plus 18 times 1.008 plus 2 times 16. So 206.274 grams of that is equal to 1 mole of that. I'm generally going to go with my molar masses had 4 sig figs. I'm going to use 4 sig figs here. But we'll see it's not actually going to matter. I would highly encourage you to write this out, to show your work here, because sometimes when you're doing that addition and multiplication, you make a mistake, you get the wrong number. If you've got it written out, it's very easy to do again. Do not round these masses to whole numbers. Okay? That is not appropriate. So here, this is telling me that 1 mole of ibuprofen weighs 206.274 grams. I'm just going to carry those extra digits along because avoid rounding errors, and there's not that many of them. How many molecules in 1 mole? 6.022 times 10 to the 23rd. So then we do the math. Oh, gosh. So I'm getting, how many sig figs should this answer have? 4. So this has 4. This one's exact. This has 4, and that has 4. So I'm going to go 5.838. There's 4, and I'm going to write down 2 extras. 83 times 10 to the 20. It's really important to not overlook that E20 on the display. So I'm going to write the rounded one down here, 5.839 times 10 to the 20th molecules of ibuprofen. Is that a reasonable number? Is 200 milligrams of ibuprofen a large enough quantity that you can see it? Yeah. Anything that's big enough to see is going to have a ginormous number of atoms or molecules in it. Okay. Sometimes people get confused and they put Avogadro's number with mole because they think that 1 egg is 12 dozen eggs. It happens. Then you're going to end up with a crazy small number. Anything less than 1 molecule is impossible. Right? Any questions?